And now for something a little bit more seedy, let's look at fruit. Be able to define fruit, dehiscent, Caryopsis, well, not for the test, capsule, pome, legume, and berry. Be able to identify where seeds are in fruit and be able to compare aggregate and solitary fruit. Dehiscent fruit is a fruit that is capable of opening on its own, usually along a certain line, and allowing the seeds out. Here's an example. Poppies can disperse seeds by the wind shaking the plant. You see how these fruit have opened near the top, making that little hat and those little holes. They are capable now of shaking the seeds out, and those seeds will go into the wind and into the dirt. Some fruits can not only break along a certain line, but will snap open and catapult their seeds a good distance. We'll meet one of those today. Saliques, samaras, and nuts. These are some fruit we're not studying, just looking at the grand scheme of fruit. Saliques are found in the mustard family. They're these little things that are dehiscent. They pop open like such. You're familiar with samaras, although you've probably never called them such. You probably call them helicopters, and they're found on maples. That's a vine maple right there. And nuts are a good favorite of things like this beautiful chipmunk. Capsules are a type of fruit found in the Liliaceae and other families. Capsules are dehiscent. They will break along lines and they will allow the seeds out. These are the fruits of Lilium candidum, which is a common ornamental plant, and the seeds can then be dispersed by wind and water or just movement of the dirt or on animals. A Caryopsis is not really a term we're going to use a lot, but it is the technical term for the fruit that we call corn seeds or wheat seeds. These are not dehiscent. The fruit is actually fused to the seed coat, and most people just call it a seed and do just fine with their lives. A pome, on the other hand, is a very special type of fruit. This is not a dehiscent fruit. It is a core with seeds surrounded by a little membrane. That's what we call the apple core, and around that is a fleshy portion of the receptacle. This is some of the parts of a flower that have been fused together. In fact, you can even find the sepals and anthers at the quote-unquote bottom of an apple. This is made of parts of the flower, and you can actually see some when you're eating it. These are the parts we don't eat, though. A legume is found in the plant family Fabaceae. This is dehiscent. You see how it breaks open along that line that allows these peas in a pod to then come out. In Scotch broom, the legumes can actually shoot the seeds up to 5 meters. They pop open, and you've probably heard them before in the late summer. With a legume, you can still see the stigma at the end of the fruit. So that little white line at the end, if you ever wonder what that is, that's a stigma from the flower. And those green things at the top, those are the sepals from the flower. A berry is found in Solanaceae. It's found in a lot of plant families. Bananas are berries, for example. These are non-dehiscent, and you can see the placental tissue connecting the seeds to the center as it's surrounded by a swollen ovule. And berries are made to be eaten. These are designed for being eaten and dispersing the seed elsewhere. You may also remember drupes, things like cherries. These were found in the Rosaceae often. Those are also made to be eaten, but that stone in the center is not made to be eaten. These are not all of the types of fruits, just a few samples from the 5 families we studied. Now let's look at some aggregate or solitary fruit. A solitary fruit comes from a single ovary. The number of seeds can vary depending on the plant. Some plants, like orchids, are capable of having almost 1 million seeds in them. Then we have aggregate fruits coming from multiple ovaries, and the number of fruits there can actually vary. So if you look at a blackberry, that's a whole bunch of single small fruit all fused together loosely in an aggregate fruit. Not a true berry at all now, is it?